Good afternoon, everybody, and welcome to our Student Placement Showcase event. I'm here, Kerry Batchelder, speaking from Barnsley Digital Campus, and we're in the DMC2 Maker Lab. And this is one of the first projects we've held in the Maker Lab, so it's really exciting for everybody on the Barnsley Digital Campus team to really get the whole space going and ready for future programmes. And today we're hosting some student engineers from the University of Sheffield, and they all applied to do this 4-week placement looking at the application of technology to different business challenges. And in particular, they're interested in the Internet of Things, IoT, and they'll be able to describe all of what they're doing in terms of looking to help businesses become more efficient and to become more productive and to solve a range of other things. So we should really mention our supporters before we kick off, and that of course is the Barnsley Digital Campus team led by Tracy Johnson. Thank you, Tracy, and many colleagues including Ben Hawley and Judy Sidebottom. Thanks so much. And also from Pitch In, and Pitch In is a University of Sheffield project which is looking at barriers to adoption of Internet of Things technologies. And Pitch In sponsored last year's project where we had some students in a similar way looking at solving challenges with IoT, and now this year's as well. And this year's is slightly different in that we've changed location, really trying to get into the sort of the region and trying to interface more closely with local businesses, you know, really trying to help them on their digital adoption journey. So without further ado, I'm going to introduce my co-host, Dr. Ramsey Taylor. And Ramsey has been brilliant in leading the project and, you know, being at the font of all knowledge around technology and really guiding the students. And so Ramsey's going to tell you a little bit more about the afternoon. Thanks, Ramsey.
Thank you, Kerry. Yeah, so as Kerry says, this is very much funded by Pitch In under their kind of heading of barriers to entry. So what we were really interested to do was get the students paired up with companies that maybe had interesting ideas they think could be solved with IoT, but either they already knew it was going to be months of development work, or they really had no idea how many months of development work it could be. As Kerry says, this is a 4-week placement, which is really not months of development work, and indeed the students still have another week and a half to go after this showcase. So in working terms, the students have really only had 7-8 working days to work on these ideas, but what we wanted was to get these bright young minds and throw them at novel ideas so they could just scope them out and see, is this a problem we can solve in a reasonable way? Is it a problem where it really is going to take 18 months, or is it a problem where there's an IoT solution, you just need to finesse it? And that's what we're going to showcase to you today. Absolutely no one has had time to make a full working prototype. No one's quite in the position of being able to say we've solved the problem. What these guys have managed to do in 8 or 9 days has been absolutely amazing, but just bring together some IoT technologies and demonstrate, look, this combination of technologies really can solve this problem, and then show you where to go if you want to develop it a bit further. So that's what you should be expecting today. It's, not perhaps finished products, but considering the 8 working days they've had, really quite some amazing demonstrations.
Thank you, Ramsey. And so today, most of our audience are online, and that's for a variety of reasons, some convenience, some with COVID issues, and all sorts. So, but what we have been able to do is still have some students with us in person. So we're going to have some live demos, both from them in the Maker Lab and also online. So bear with us. We're going to be trying some new things, trying to bring the camera over so you can see some of the demos. So yeah, we're hoping for a glitch-free event, but I think just if you could have some patience, that would be really good. So I think we're ready to get kicked off. Exactly. So,
and of course, questions in the chat, and we'll try and address them as we go.
So we're going to have 3 main themes. And this is smart city, healthcare and social care, and manufacturing. And within each of those sections, a different number of talks. Some of the students have all been, say 3 have been working on a similar challenge, and then they will present together in a kind of group. Others will have standalone projects. So we'll just guide you through that. So like Ramsey said, Shamoil, I think, are you ready? You are the first to talk. So I'm going to let you introduce your title and your presentation and take it from there. Oh yeah, he's good to go. Okay, Ben.
I'm just inviting the screen.
Should we get a...
Hi, can you hear me? Awesome, thank you. I'll go ahead and share my screen. Awesome. I hope all of you can see the slides. If that's the case, I'll start the presentation. Great. So, hi everyone. I am Shamoil. I am a second-year mechatronics and robotics engineering student at the University of Sheffield. And today I'll be speaking about automating weather data collection for predictive road maintenance. So, over the last 2 weeks, I've been working with Kevin and Greg from Mobilize Construction. Mobilize Construction is a business that provides real-time citywide data to identify road deterioration before road hazards appear. So essentially, this technology digitizes road management to create smarter cities. The challenge that I had been working on over the last 2 weeks was to automate the collection of weather data in Barnsley region and regions around the globe to aid in this prediction of road deterioration and maintenance. So this would involve continuously monitoring the weather data source, making the program sleep when updates are not available to conserve resources, and then downloading the data sets once updates are actually available, and then running the next process in the software pipeline. So how did I approach the challenge? Well, the first step for me was to explore the different weather data sources that are available. After going through a few of them, we sort of finalized on the Copernicus dataset, which is a very wide, reliable, and a high resolution dataset, which is used for lots of research purposes. And the best part is that it is open source. So once we had this in mind, I wrote the Python script, which is now involved in checking if any updates in weather data are available from this Copernicus API. If the updates are available, then downloading the data and then stitching the necessary data pointers in Python to then feed this into the company's tech pipeline. Some of the helpful modules that I used in the process included Pickle, NetCDF4, gzip, and Pandas. I also used the QGIS software to visualize road and motorways in the UK using data available on the UK government website. So this software is now currently collecting 37 relevant weather data pointers, such as temperature, dew point, precipitation, etc. And this data feeds into Mobilize Construction's software, which then predicts road deterioration and ultimately makes roads safer and more accessible. So what's next? Well, weather is just one piece of the puzzle of all the variables that affect road conditions. And so Mobilize Construction have installed various sensors on a few cars in Barnsley to measure the road profile while the car is moving on the roads. So my next project will be based around using these sensors, which are essentially accelerometers, gyroscopes, and GPS data to measure bumps and cracks on the road surface. As a starting point, this can be done by determining the roll and pitch of the car, which can be used to determine the longitudinal profile of the road while the car is moving. So essentially, this would identify the orientation of the car with the road and hence help identify any bumps or cracks on the road surface. Some of the challenges that I foresee while working on this include, firstly, car suspension systems can hinder the detection of bumps. And so there might be a need to explore onboard diagnostics or OBD car ports to get data directly. Secondly, there might need to be a way to differentiate between sensor noise and minor bumps on the road. And lastly, the data pointers from these sensors are collected across different frequencies. So they might need to be interpolate the data points that we have as required. So even though the project was just 2 weeks long and just 2 weeks have gone by, I've had the opportunity to learn quite a few things. Firstly, I understood how important it is to understand the physical meaning of data that you're working with. For example, understanding across what time spans and at what frequency the data was collected. One sort of aspect that helped me with this was visualizing the data. For example, with matplotlib in Python and in Grafana. A second learning was understanding the importance of researching and eliminating noises in data sources. For example, with data preprocessing, bootstrapping, or applying low-pass filters. Thirdly, data which is difficult to collect can be leveraged, for example, with finding a correlated yet easy to access data source. For example, trying to interpret road occupancy from CO2 levels in the city. And lastly, I had the chance to explore software reliability for the code that I had written. So this involved writing a few unit tests for the code that I wrote in Python. These unit tests would help ensure that any future integration of software in the tech pipeline for mobilized construction would make sure that the code doesn't break, and it would make the automation process of the software even more easier. So I have picked a lot of analytical and software skills over the last 2 weeks that will definitely aid in my degree program and even in future placements. So I'd like to conclude by thanking Pitchin, DMC, and all of the wonderful mentors who have supported us over the last 2 weeks. But that'll be all from me, and I'm happy to take any questions.
So it's back on. So.
Yeah, you're on now and you can be heard.
Okay, just let us know if there's any questions. Yeah. Okay. Shamal, thank you very much. That was excellent. In a very short space of time, you've really achieved a lot.
I think it's fair to point out Shamal is not only not in the Barnsley DMC, he's not in England at the minute, so he's been doing this very much remotely.
Yeah, exactly. So a question from me is that I've spoken to Kevin Lee from Mobilised Construction, and I know one of the challenges is about getting the kind of road data that perhaps you need to look at. Have you got any suggestions about how you could best gather that data? Any suggestions?
I think while sort of researching initially when I got this project brief from Kevin, I looked into a few methods, first of all, in how the UK government does it currently. And how they do it is by employing a scanning process of the roads called Scanner, quite intuitively, and another one called Tracks. And what this does is they sort of send out trucks on roads around the UK, which have cameras installed underneath the cars, and these can sort of measure cracks, textures, any sort of profile variances of the road as they move on the road, and then they use that data to calculate whether maintenance would be needed for the road. But I think in the future, just to help with creating more robust predictive maintenance approaches for the roads, it might be better to include other data pointers. For example, like I mentioned, weather, which can be a huge sort of factor in terms of road conditions in a city. Other factors might include, for example, with how mobilized construction have used sensors on cars to detect bumps. So it sort of measures in a way the same data that a tracks or scanner truck would, but the costs associated with this are quite low. So I think to answer your question, the sort of data to collect it might be similar across different sort of cases, but I think the focus might be on if there is an innovative way to sort of capture the data itself, and maybe in a more cheaper way.
No, I think that makes sense.
Yeah, good. Thank you, Shamal. Right, I think we probably should move on to the next speaker. Much appreciated. Thank you.
Thank you.
Very good. Right, next is on my list. We're now moving on to the healthcare challenges, and there's a couple. Manon, Charlie, and Ben will talk about the first one, which they're responding to. Thanks a lot, Manon.
Introduce us with a big shot.
Are you all three coming up together this one?
Yes.
Yeah. That's what I'm just checking all three on stage. Then try and find Ben.
Yeah. Don't pull your laptop.
You all talking at the same time?
No, it's me, then Charlie, then Ben.
Right, so if you want to talk first, because you can still be heard now. So.
Yes. Okay. Hi. So we are here talking about a physiotherapy-based project. This was, yeah. So it's Charlie, me, and Ben who've worked on this one. You'll hear a little bit more about each of us as we present our individual takes on this project. So this project was presented, this brief was given to us by Andrew Jackson, who has 40 years of experience. He previously worked for B. Braun until very recently, which is where this kind of brief comes from. So it's a brief of helping physiotherapists track the progress of their patients whilst they do their exercises at home. So many of you may have done physiotherapy before. You're given a list of exercises. You're meant to do those maybe once a day, maybe twice a day, a couple times a week, and you then will see the physiotherapist again. We were given the brief of using the Internet of Things, so sensors, wearable tech, or something similar, to track those exercises whilst you're doing them at home, and then providing feedback to the physiotherapist to see So the challenge then also was to create something easy to use, lightweight, low cost, and as I said, feedback. So firstly, I will go through how I answered this brief. So I'm Manon, I am a computer science student, and I've created this device which I'm wearing on my leg. So I am using a magnetometer, and the things you know, this means that the magnetometer receives an X, Y, Z axis coordinate from the magnetic field of the Earth. And then my idea is that you will is that you take these and you measure the angle between your start position, your end position, and this shows you the range of motion of the user. This will give live feedback to the patient through an LED, as well as transferring the data back to the physiotherapist so that they can see how they're doing, if they're improving. I will now do the demonstration of this before I move on to the next steps. So, as you can see, I have two buttons here. One is reset, one is for practicing. So I now set it up. You press this button. The LED goes green to tell you that it's ready. You move your leg to the position of the first movement. Hold it there until the LED turns off, and it has now recorded the position of the first movement. It will then repeat this, and then save the data again at that position. And when it's saving this, it is saving the angle between the start position and the end position, which is basically telling you the range of motion, how much you are managing to move. Obviously, this will improve as time goes on, hopefully, if you are doing your exercises correctly, which is the main indicator of if you're, there we go. So that is all the movements set, and you then press the second button, and you are given an amount of time to try and reach the height you previously did, where the LED should turn green. To tell you that you're done that. It's a little bit temperamental, as we've only had a week to work on this. Yeah, that's the gist of it. So the next steps of this, currently it's all the stuff you see on your leg. The next steps of this will be transferring the data to the Things Network, where it will then be grabbed by Raspberry Pi and hosted on a web server, so that the physiotherapist has graphs and can visualize the data that we gathered. And then just to finish off, I'm personally interested in this because I'm very interested in medical healthcare tech. Currently just finished the second year of my computer science degree. Next year I'll be doing a dissertation in wearable tech and how it can be used with medical devices to monitor chronic conditions. With that, I'll also be looking into web app development, which I'm very interested in, and I want to go into more hardware and wearable tech. Yeah, I will now pass to Charlie for her demonstration.
So, hi, I'm Charlie. Sorry. And I'm doing the same challenge as Manon, but I took a slightly different approach to it. So, my approach, I wanted to focus on the fact that it was easy to use so that patients could use it at home unmonitored, really leaning into the focus on the at-home recovery. Obviously, it had to be lightweight because it had to be wearable, and I wanted it to be low cost because if the patients are going to be taking these home, there's a chance that they could get damaged and things like that. So the components of it are a potentiometer, an elasticated leg strap so that it's resizable to different size legs, and also so you could use it on different joints, so you could adapt it to use for the arm, and a things that you know. It's also based on an existing harness that I found that's used for paralysed patients. So it's a brace that they use, and they can release a mechanical spool to put their arm into different positions so that it's more comfortable for certain activities. So the current uses of it would be, is the patient moving frequently? Can they hold their stretchers? And is the patient's range of movement increasing, and at what rate? This would be sent by the feedback from the device, which I have here. So hold on a sec. Okay. So basically what we have here is just the battery, the board, and the potentiometer. And the potentiometer will send the angle and the time that the patient has managed to hold that angle over the Things network, which will be able to give you all of the information on this screen. But my hopes that the things I'm currently working on are being able to graph this data so you can spot unexpected trends. So maybe they are taking big dips in progress or something like that at certain points, and you could monitor that and work out how to overcome that. And also an indication for the patient when they've extended their range of motion or met a personalised target position and time. So just like a small device that would vibrate or a light or something like that. And I also am currently making an application for the patient and physiotherapist to use so they can navigate the data in a much more user-friendly way rather than just having all of the raw data for them, which goes hand in hand with the graphing. Yeah, and I will now hand over to Ben.
Cheers. Thanks, Charlie. Can I? Oh, I can share my screen now. I couldn't before. 1 second. Right. So I can no longer see people, but I assume if I don't get a shout that you can see this. So I'm Ben Campion, and I'm a bioengineer. So naturally, I was also drawn to the more healthcare problems. So I've focused I'm still doing the same challenge, but I focused it looking at lower limb therapies and specifically balance because it is a topic that's quite close to home. So here is my knee from a few months ago because it's got an unfortunate habit of bending the wrong way, and I've dislocated it 3 times now. So I'm quite familiar with doing physio for my leg, and one of the main goals of that is to get stability in the joint. So that's why I'm focused on stability. So there's 3 things that I'm looking to get out of my device. So I want to know, is the patient doing the exercise? Because it's all well and good doing it for 30 days, but are they actually doing it? I want to provide some kind of performance parameter to the physio just so they can track the progress, as well as some real-time feedback for the patient just to give confidence that they're doing the right thing. So my concept is to have a wearable device that would go maybe on the chest or the shoulders, and that will track the stability as well as just the length of time that the patient is exercising for. And then whilst they're exercising, it gives real-time feedback via a traffic light system. So it's just, so if you're stable, you get a green light. If you're way off balance, you get a red light. And then in between is amber. And then when the patient's done with their exercise, they push a button, and then the data gets analyzed and then sent to the Things network for the physio to take a look at. So at the moment, what I'm transmitting is a basic balance score, which is kind of things like average angle that they're at and how long they were doing it for. So how I'm doing this, at the moment, I've got a gyroscope and an accelerometer. So that gives me 6 degrees of freedom. So I've got acceleration and angular velocity. And from this, I'm able to get my roll and my pitch and kind of yaw. So you've got, so pitch is like that, roll is like that, and then yaw is your heading that way. So when it comes to stability, you should only need your pitch and your roll. It doesn't really matter where you're facing. Well, that's what I thought, but that's not exactly the case, but we'll come on to that. So this is my device, and again, please shout if the video quality is not great, but I think it's fine. So what I've done here is mapped my device to just a graphical interface, and you can see that the pitch and roll are tracked relatively well. So as I tilt and roll my device, I'm getting the right data out of this, really. Tilt to the right, tilts on the screen. And you can see at the bottom, you've got little traffic lights. So when it's level, it's green, and when it's off balance, it's red. Now, doing this shows two problems. So the first of which you'll see now, which is when you twist it, change the orientation, the yaw, it does actually mess up the other angles. So because I was moving the yaw there, even though it's level, it's now pointing down, which it shouldn't be. We'll come back to that. The other issue is drift. So the accelerometer and the gyro, they lose accuracy over time. So what this plot is the blue is the roll and the red is the drift. So these are both what are calculated from the gyro and the accelerometer. And so it's just level on a desk. So they should be at 0, but they're not. So at 0 seconds, my device is accurate to about a degree. By 30 seconds, I'm down to 5 degrees. However, this is relatively consistent. So it's not necessarily a huge problem. Because what we can, so this is the same kind of graph, except I'm now moving the device around, and you can clearly see peaks and troughs. And you can see where the 0 is kind of drifting. There's like an imaginary line across each of the data points. But yeah, the peaks and the troughs correspond with being off balance. So it is still usable, you just have to account for the drift if you're using a gyro and accelerometer. So the next steps, potentially to get around that, is to use a magnetometer, which I'm currently playing around with but haven't incorporated yet. So what a magnetometer is like a electronic compass. So that will give me my heading, and that should prevent the issue of the yaw messing up the other axis, and it should help with the drift as well. The device will also need calibration because a lot of the tech and the code is designed and adapted from like robotics control, so drones, that kind of thing, things with very precise measured movements, exactly what humans don't do. So that needs calibrating. And then these last 2 points are more end user things, so not necessary for proof of concept, but you would want to do these. So analyzing, like, at the minute the device just transmits, you do the the exercise and the device transmits it. The device transmits it. You want to see, are they getting better with time, and are they consistently doing it, that kind of thing. And then finally, because I think I'm pushing over time now, just a quick bit on how the project is going to help with my career. So as I said, I'm a bioengineer, and what I'm really interested in is the product development of medical devices. And well, medical devices are becoming smart devices, really, and you just need to look at people like Google, Amazon. They're all getting involved in the medical devices and the healthcare industry because this is what they do, and these are the skills needed now to buy the medical devices. And then the product development stuff, I mean, we're taking a concept and very quickly working out if it's possible. So this will inherently help with that. So yeah, that's about it. Any questions, please come chat with me, and thank you. Can I stop sharing? Yeah, thank you.
There we go.
Brilliant. Thanks very much, Ben and Manon and Charlie. I was really blown away actually by the fact that all of your different solutions could actually come together to be this real kind of program for recovery with people. So I think maybe you should start a business actually together. I think this would be a great plan.
I certainly pick up though for the people in the audience, and Ben mentioned that he's a bioengineer. There's several of these students aren't software engineers or electronic engineers, and yet we've flung them into this IoT and electronics world. I mean, I could spend the next half hour talking about multidisciplinary teaching at the University of Sheffield and how it produces wonderfully rounded engineers, but these are case studies in that.
Brilliant, Ramsey, thank you. So the question I had was about the fact that, you've been in the Digital Media Centre in the Maker Lab, you've come up with these great ideas, but what would you do if you needed to actually engage with the people that were going to either make use of it clinically or as patients? Any of Charlie, Ben or Manon, what would you say in terms of how would you approach that? Manon, if you want to come up, you can. Not that I'm literally putting you on the spot. Charlie or Ben, any thoughts about that?
Can do. Yeah. Well, I guess it'd be the same as. Well, I suppose I've got the benefit from my course of knowing a bit about how medical devices are brought to market. I suppose it'd be the same as that. So you would look at getting early adopters. So that might just be a single clinic or single hospital or wherever to really work with you and develop the product and test it. And then you'd have to go through all the regulation, prove that it's safe and what have you. And of course you need data for that. So yeah, so the main thing is you need to get some contacts, get some people that trust you enough to let you loose with a product that's not fully developed and develop it and get the clinical data basically.
And I think that's where I was sort of kind of going with this. The fact is, you've got to have the people involved. You've got to have the users at the centre, even if it. I don't know if I'm on camera or not. Even if it's a technological development, you want to have people at the heart of it. Making use of kind of user-centred design. Manon or Charlie, did you want to add to that?
Yes.
Okay. Yeah. Go for it. Yeah.
So actually my dissertation next year will be on creating some type of hopefully wearable technology which will be tracking people with chronic illnesses. So I'm actually really hoping that I can get ethical approval from the university to talk to them, see what they actually need, talk to them about their specific symptoms, and hopefully possibly get them trying out some IoT pieces. Yeah.
That's fantastic. Thank you very much, Manon. And I think you can see our students, could really bring some real game-changing advancements to, the people of our region in terms of helping with health and well-being. So thank you so much, all of you. Any questions, Ben, or should we? Oh, Charlie, sorry.
Oh, I wasn't saying anything, but I could add to it, just really would just be echoing what the others said of it's important to work with the patients for their individual needs, and in our case for the physiotherapist for the exact details that they would need about the patients. Yeah, I think Ben and Manon said it really well.
Absolutely. Well, really well done, all of you, and hope Andy is very pleased with what you've done. Lovely. Okay, I think we'll move on, if that's all right. Okay, yeah, thank you very much, all of you. Thanks a lot. Okay.
As we change over.
And we are on to Casper, if you could get ready, please. Casper's joining us online. Okay, brilliant. Okay, great.
You need to put your camera on, Casper.
Yeah.
Now.
There he is.
Okay, hello. I'm Casper. I just share my screen and okay, can you see the presentation? Just come back. Okay, so yeah, I'll be presenting now. Sorry. Okay, so so I'm Casper. I'm also a student at the University of Sheffield. I study electronic and electrical engineering, and today I will be showing you the problem I was trying to find the solution for, which is a parental nutritional for healthcare as well. So what's the challenge? It's also given by Andy Jackson, who was mentioned before. And the other problem he's facing currently is some sort of automation process. So basically, they send some medical suppliers, but the whole process is done manually. So they send some medical suppliers from the hospital or like the place they store them in special fridges to the houses, and then the drivers, they collect data manually. So they collect data and check what's the number of medical suppliers in that house and how many are left, and then they collect that data, send it to like the database. There's like another company that stores that data, and then they have the database and they update the database every day. So basically they deliver those packages like twice or three times per day, per week. So they don't have information about the temperature of the fridge, which they need to keep sensor temperature to keep that medical supplies in the certain threshold, and then they don't have any info about how many bags are left. So it's very, very old-fashioned for now. So I was thinking on the ways how we can use IoT devices to automate it. And so there's my prototype. So the idea is that instead of collecting data manually, we'll use a simple weight sensor and temperature and humidity sensor. So because those bags, they have the same wave, they have the certain weight, so we can easily calculate the number of bags knowing their weight and send that info using to TTN and then store it in database. So knowing that, we can update update the information about the stock every day, or even like twice a day, depending on our application, depending on our needs. And additionally to this solution, I added few things because we don't want to constantly run the Arduino board, the microprocessor ongoing, because we waste some power. So I added some, so I program it, and I have like the code that turns Arduino in the sleeping mode. But maybe I'll just like show you now on the camera and present what I mean by that. So let me just show this. I will stop presenting and I just. Okay, so here is like my model. So we have here some buttons. I use buttons instead of the clock for just like this presentation purposes. But basically the idea is now Arduino is in the sleeping mode. So if I turn this button, it will be on. I'm not sure if you can see it. It's kind of like I do this way. So because it changes here. Can you see it like normally? Because can you like put some thumbs on or something so I can know that it's working? Anyway, on the screen it's just displaying the data and some like comments. So now if I press this button, I'm actually connecting to the TTN and sending some information. And then I can collect this data. And yeah, so now it's processing it. So now first it had distance, because here's like a ultrasound sensor. So it measures the distance. I did have the idea that we can use as many sensors as we want. And now we have some sort of function called reminder, because with elderly people, there's a problem that they might not know when to take those medical supplies. So if I press this button, I release the sound. So now I actually have that, but here we have like a buzzer that it's using like 1.5 kilohertz frequency, but it's not the most important bit. The important bit is like, instead of using buttons, I can program it using the clock, real clock, and say that at 4 p.m. each time, I can set the reminder for those elderly people. So the reminder will be like, the speaker will be connected to the Arduino board, and it will be saying that please take the medicines, or please do this or do that. So it's mainly to show you that the functionality of this device. So if I share my screen, I can show you that I can even send the message back. So now I'm in my console, and now if I go to downlink message, I can say the downlink message is like 1. And if I schedule this downlink message, and now I will stop sharing again to just show you. Now I turn on the whole board again. So now I will connect to TTN server again, and one of the LEDs should turn on. It takes some time, but yeah. So now it's the red LED is on, and yeah, I will turn it off in a second. But anyway, I will stop. I will switch my camera again and show the presentation. Okay. So basically the idea of it is like to send data using LoRa network, and because we only need to send this data like twice a day or like once per day, then the LoRa network is perfectly suitable for this because we have limit of airtime, but like to 30 seconds per day for per end device. But it perfectly suits this because we only need to send data about temperature and the number of pipes. But apart from that, we can still run the code, and the loop can be executed as many times as we want it to be, to check if the temperature is okay, and in emergency situations, we can send the data and to the other side, saying, oh, the temperature in the fridge is not sufficient, we need to change it. And then the person at the other side can send a message to the fridge, and I don't know, and change the temperature, or like control the fridge temperature, or like cut off the power. And it's what I just presented to you with this simple LEDs. I saw a message from the network to Arduino, and I turned the LED on. But the concept is that you can do it with whatever you want to. So that's the one way. Then the other thing is it's the power consumption. So as I said, the Arduino is off unless I press the button, but I can set up some timers, so I can turn Arduino to execute the loop like every, I don't know, 1 hour, 50 minutes, 1 minute, it depending on the application, depending on the needs and the requirements. But the idea is like it's very flexible. We can, with this solution, I can go any direction. I can go for more like user friendly, for more like I can add another sensors and some sort of like interface. Like I said, that reminders about when to take medicine, or like I can add even more functionality to this, or I can make it even simpler and just send the information about the number of packs and the temperature in the fridge. And with a folder and create application, and instead of the person who is like collecting the data in the database and sending drivers to locations where they have to deliver those metal suppliers, I can create an application that will be checking all of the data and just sending a message to each driver saying, oh, go to this place, go to that place. So we can like fully automate that. But it's just like a prototype in like few days that I've done. And I was my focus on the question, but now I know that it's something achievable. And also with IoT devices and LoRa network, it's like wide coverage. It can be easily the network can reach anywhere, because even if there's no coverage in particular place, we can use like an indoor gateway and send that data. So basically, this solution can be implemented in any house. So the learning outcome of this project is like I enhance my programming skills. As electrical and electronic engineer, I don't have, for example, access to like JavaScript or like Java. So I was working on like some Node.js, and I tried to retrieve data from the TTN network, which I done successfully, but I couldn't display it in a neat way yet. So I didn't present it today, but I can retrieve it, and instead of using network, I can just like have an application, and from the application monitor everything. And that it's very useful for me because exploring this network and IoT devices capability, it's very useful for me because I'm working on some projects where I build drones, and I'm mainly responsible for communication with those drones. So like exploring the capability of IoT devices and LoRa, it helps me to and it shows me the what I can achieve with that. And it is also very useful to fill the gap in programming skills, because I'm very interested in programming and in electrical and electronic engineering course. We have some modules about it, but not that many. So it's very good to see that. And yeah, I still have to like create a database, which I'll be using Raspberry Pi. And then I will try to find the balance between power consumption and the functionality, because as I said, it's very flexible. It can go in any direction. And so just to briefly summarize the presentation, so I gave an introduction to the challenge, to myself, and then, as I said, the solution is just to use height and temperature sensor, sending this data to TTN and retrieving it from the network, and then to automate it even further, we can add some functionality like reminders, like emergency situation. We can control the whole fridge and the temperature of the fridge from on the other side of the network. And another stage is just to fully automate it with application. And then I just said about the learning outcomes. So thank you for your attention. And if you have any questions, I'm happy to answer.
There you go.
Thank you, Chancellor. Excellent. Yeah, really covered a lot of ground there, so it was really good to hear. Thank you very much. How have you felt in terms of you being an electronics student? Did you find that this kind of approaching this kind of challenge was quite straightforward, or have you, what kind of things do you feel you've mainly learned personally?
Just like in terms of electrical students, you said. Yeah, okay, so in this challenge, like what was the for me as an electronic student, it was more like the software, like retrieving data from the network, because I don't have JavaScript, I don't have Java, but in like few days I managed to actually retrieve it. I couldn't display it. And other challenges is just like finding the right balance between the power consumption and the functionality, because with the LoRa network, there's some limitations, like the 30 seconds airtime. So it means that per day we can send the information to TTN only a few times, and we can send it in bytes, which is not a problem for our application. But we shouldn't send it like more frequently than like twice a day, because there's no point, and we need to have that buffer for like some emergency situation. So if the program sees that the temperatures goes below or above the threshold, then we need to send that to that information to network, so someone can receive it, and the person on the other side can do actually something, because there's like a limit of 10 downlink messages. So it's actually a lot. So the problem can be sorted. And another challenge is just, I don't think there are any more challenges. It's just like more about exploring the functionality of Arduino boards or of LoRa network. And, you know, as I said, there's a lot of like directions that can be taken from it, and then similar solutions can be applicable not only in like in medical and healthcare sector, but even in other sectors where we just have to retrieve some data and do something. But yeah, I think that's it.
Francie, did you want to comment?
Well, I mean, more as a comment, I mean, one of the interesting things with things is demonstrate the downlink capability of the LoRa network as well. When we're talking about IoT devices, almost all sensors that can pull stuff up, but that's what this is. There is the opportunity to control responses downwards and can be remarkable. Yeah, I think it's fair to say Casper started last week with enough ideas for about 18 months. So I've got to do anything 6 or 7 has been quite good. But yeah, that was impressive.
Well done, Casper.
Okay, thank you.
Raquel, are you ready? Yes. And if Mark's on the line, Mark Howell, Raquel has responded to your challenge, so I'll hand over to Raquel. Thanks a lot. Justine.
You want?
Justine, apparently he's trying to get.
I'll hang on 1 second. There you go, doing a control.
Thank you.
There we go. Hello everyone, my name is Raquel Hernandez. I'm a second year aerospace engineering student, and this past 2 weeks I have been working on thermal monitoring of the sleeping patterns. Okay, so the challenge was given by Mark Howard from Federal Partnership, and he asked us, how can we use IoT to improve the quality of the carrying sector? This is the device I came up with. There you go. It is basically a temperature sensor that is placed inside the bed, more precisely inside the pillowcase where the neck goes, and it would tell the nurses and carers whether the person is in the bed, out of the bed, or if the person has fever. The data will be displayed on a graph like the one in the top right corner, where the blue line is the temperature in real time, and the red lines are boundaries. The top one will indicate that the person has fever, and the bottom one that the person is not in bed. It also has a yellow line that is a trend line, so it's easier for the nurses to tell, oh, the person might not be in bed. The good side of this device is basically that it has no cameras, so it protects the privacy of the patients. It is also a good way to reduce the reaction times in critical situations. Although the devices work, there are some things that we can do to increase the reliability, efficient, comfort, and speed response. One of those things is using thermocouples. Why is that thermocouples? Because the response is much faster, and also because at the end it won't have a chunk of metal, which the sensor I've been using has. Therefore, they will be much more comfortable in bed. Another option would be to use infrared camera sensor, which in my opinion is the best option, mainly because it has extremely fast response, and also it doesn't have any components inside the bed, so it will be much more comfortable. The counterpart is that it kind of compromises the privacy of the people, since after all it is a camera and some patients may feel uncomfortable with it. But as you can tell, the image is very blurry and it's very, very small, so I don't know, it kind of depends on the patient. And of course it's a bit more expensive since the component is a bit more complex. I would also suggest adding a pressure sensor plus the temperature sensor, because this will increase the efficiency, since it will work as a trigger to the temperature sensor, so it wouldn't be censoring a temperature when there's no one in bed, and also make it more reliable, since it is one more data that the nurses can use. Sorry. It's more complicated than I expected. Okay. So talking about the network, I think it could be improved. The one we have been using is the TTN, the Phoenix network, which in my opinion is doesn't have many security. It's quite poor in that sense, since it requires a third-party security. Regarding integrations, they could stop being supported by the TTN, like it has happened with Node-RED, for example. Therefore, you might install your device, and in 2 years from now, the integration may not be supported and your device won't work. Another aspect is that the instructions that are provided are very limited. Therefore, installing the device is quite complex, even more now if the integrations are not supported anymore, since you will have non-updated information on that. Therefore, in general, it requires a high level of technical knowledge. So the alternative that I propose is using Wi-Fi. First of all, because even though you use the TTN, you also need Wi-Fi to display the information on Grafana with the Raspberry Pi. So why not taking out one of the steps that will reduce significantly the possible errors? Moreover, the intent of security, it has a wide range of options. It is easier and much more flexible to solve. There are many instructions of type. It's easier in terms of scalability. And that would be all. Thank you very much. And if you have any questions, I will try my best to answer them.
Stand next to it.
You go back.
The stage.
So-
Yeah.
Just pass it to them.
Oh,
Then I can
thank
take
you.
the screen.
I'm
I
sorry.
don't know if there's any questions online. I was about to take issue with this slide. But
Okay, well,
Yeah. I mean, I think that this is actually a problem, frustration of mine with a lot of the IoT community. Is we blur the line between LoRaWAN and TTN and a whole stack of different technologies that are actually going on, which I think you could split part way. I mean, I agree with all of your criticisms of the things network for use in critical settings, but the LoRaWAN is only the wireless bit at the bottom. You could still use that and skip the kind of open source server somewhere in Germany that we don't necessarily trust and redirect it somewhere else. There's problems with going to Wi-Fi, and it's much more energy consumptive. So getting the good bits out of LoRaWAN at the bottom
Yeah, of course.
and skip the, I have lots of concerns that people are going to start doing clinically relevant things and pushing them up to indeterminate bits of the cloud, but there's ways to break that LoRaWAN stack, lower down and direct it somewhere a bit more secure. We can have a long conversation about that.
Yeah,
I'm not sure
probably. I mean,
people
I
in the
haven't
audience
really
can as
worked
well. But no, but this is something that, again, there's lots of new technologies in the IoT sphere, and various bits of different things get bundled, and it's presented as though you have to take the whole thing. And really, we can filter some of this stuff out. But the other thing, several of us have already seen it and talked to Raquel. We really like the idea of some of these much less invasive ways of doing people monitoring in the homes. That wasn't a question, that was just a spiel. But
Thank you.
So-
I appreciate it.
But monitoring. Okay, so in general, it would be a way so nurses and carers don't have to be constantly checking the rooms to see if everything is all right. For example, in hospitals, you have a monitor, but for elderly houses or things like that, where you don't really have that kind of technology, it's an easy way so the nurses and carers don't have to be constantly checking all the rooms, and the reaction time in critical situation, if it is a person that cannot really get up of the bed, so probably maybe they fall or something like that, so they will have an instant notification that that person is not in bed. So that's the main idea behind it. Hope that answers your question.
Well, thank you for that. That was good.
Okay, well, thank you very much.
We go from there.
Manufacturing.
Yeah, he's good.
Go for it.
Yep.
So which slides do you need up first?
Visual measuring. Yeah.
Perfect. There you go, mate.
Hello everyone, I'm Christian Calistro, and alongside me Felix Randall, Sam Niels and Yazan Kader. I hope I didn't mispronounce your names too badly. Are going to present different methods of measuring different parts using machine vision. So the challenge presented to us by Alex Kelly from Tinsley Bridge was that at the moment they are using a jig to measure their roll bars, which is not only time consuming, but it requires a lot of human interaction. And up here you guys have an image of the jig that is currently used to measure the roll bars in their warehouse. And we're planning on replacing that. We were advised by the client to look into computer vision methods to measure the parts, as they mentioned to us that they have a lot of CCTV cameras available in the warehouse. And the client also mentioned that the ideal measurement tolerance should be around 1 millimeter, which we haven't achieved yet, but we're working towards that. And now if we can switch to my slides. So now I'm gonna move forward and present my approach for this project. That is me, small in the corner. I'm Cristian Adrian Halistru, and I'm an aerospace engineering student at the University of Sheffield. And my project is camera measuring system for manufacturing businesses. My approach was to use a Python script that uses a library called OpenCV, which specializes in image processing. The building block of this whole script is going to be the pixel per metric ratio, which is a constant across the whole frame of the image that is calculated using the object dimension in pixels over. The OpenCV library gives us the possibility of measuring the object dimensions in pixels. So we already have the first parameter. And for the second parameter, my idea was to use a reference object so we can have a known dimension and so that we can get the measurements for the other objects as well. Starting from that, I chose to use a piece of paper, mainly because I was doing the measurements using a webcam on my desk, and my desk is gray, so I wanted something that is a contrasting color, doesn't blend with the background, so I can do better edge detection. And then my method requires the object to be on the reference object, and then it gives the dimension. And in those three bottom images, I'm gonna go through the algorithm. So the first image is a black and white image. So basically I'm converting the original image to black and white because it requires less computing power if it doesn't have the colors. After that, I'm doing what is called canny edge detection, and I'm detecting all the edges in the frame. Then I skip 2 steps because you can't really tell the difference from the images, but I do a dilation and erosion of the edges so I can get better definition. And then I use these edges alongside the pixel per metric ratio that I have already mentioned to give the output that you can see in the third image. So the contours and the dimensions. However, my method is not perfect, and in the following 2 weeks I'll work on improving it. At the moment, I'm not taking into account the intrinsic characteristics of the camera, which means that the camera adds to the inaccuracy of the results. That is because the lens are actually distorting the image. The resolution of the camera differs when we switch the camera, so we have to take all those parameters into account so we can have an accuracy as close as possible to the original result. So I'm planning on working on that, and I'm also gonna implement another angle of the camera because at the moment my method is dependent to a vertical view of the object to get accurate results, and I'm planning on using angle view in the future. I'm also planning on replacing the reference object. As I said, I'm using a piece of paper because of the contrasting background, but I'm planning on using the tape on the floor that you can usually find in factories. As you can see in that image, you use that for reference. But for that, I'll have to improve my sorting algorithm. And last but not least, I will improve and create a data transmission system because I didn't manage to do anything with the things internet, things network. So I'm gonna try and implement that. At the moment, the results are displayed on the screen if you're running the code on a Windows laptop. If you're moving on a Raspberry, which runs on Linux, the results are gonna be saved on an Excel file. And how did all of this help me in my future career? Well, as I said, I'm an aerospace engineering student, so I didn't really code before coming here. I had some experience with C and Arduino, but it was my first time working in Python, so I can say I was pretty much a monkey when it comes to Python. And now I can confidently say that I can work on future projects using Python, so I'm probably somewhere in the middle, and I'm aiming to getting to the experience stage. I also learned how image processing works, which doesn't only help in measuring objects, but it also helps in sorting objects, object identification, which I think are all very valuable skills for a student who pursues a career in avionics. And to conclude my presentation, I also worked for the first time with a Raspberry Pi, and I saw its capabilities, and I'm keen on working on future projects using this device. Thanks for listening, and after my colleagues are going to present their methods as well, I'm going to run you through a live demo of my method. Thank you. And any questions?
I think
You will do them at the end of the
Yeah.
Okay.
On to me then. While that's loading, hello everyone, I'm Felix. I'm a computer scientist. I didn't put my LinkedIn, didn't think I'd go that far. Can't get everyone else. So yeah, similar to Christian, I'm using computer vision to measure different parts in manufacturing. Next slide. I'll do it.
I'll do it, it's fine if you're on. So no.
There you go. So how did I approach this? I approached it a bit different with Christian. I used these Erico codes that you can see in the top right as a reference for where I'm going to be measuring. So you place them in a rectangular shape around some area, and then any objects that are within that area we can measure. So to do that, we're using known sizes on the image. So we're using the sizes of the markers themselves, we're using distances between those that are predefined. And then again, we're using that pixels per metric ratio. The magic ratio, I'm just going to refer to it as that from now on, to then determine the size of the object within that frame. This does, however, mean that it's a very complex setup in trade for micro measurements. So with the setup, you need to know the exact measurements of the markers and the distances, otherwise you're not going to get accurate results, as I learned when the 3D printer decided it didn't want to be 60 millimeters. And it also means that you need a very specific camera setup. So if the camera is slightly off tilt, then you're not going to get accurate results. And while I tried to build some things to protect that, it didn't really work. And obviously if your camera's off to the side, different perspective, it's not going to be getting the measurements that you want. They might be measurements, but they will not be right. So next slide, please. So, I forgot to mention, I did manage to get measurements within around 1 millimeter with the setup that I have now, but again, if you go even slightly off, that grows to about 2 or 3 millimeters, which starts to become unusable in most manufacturing settings. So the main step, one of the big steps next is to improve that. I believe that I'll be able to get that down consistently to around 1 millimeter with a good camera setup. And that's going to be the first thing that I do after this. After that, the big thing I want to do is automation. So right now, when you place it in, it shows the measurements on screen, but it's basically the same at that point as putting it in a jig, because you've still got that human having to go in and make sure that everything's correct. It's just that now, instead of them placing it in, they've got to go and look at a screen, which doesn't really help anything. So it'll be, there is a reason the traffic light's there. it'll be going towards a traffic light system. So if we know that the part is the right size and it's within the accuracy of my system, getting a green light, I'll say, yeah, that's good to go. If it's probably right, but there's a chance that it's not, it's close to that edge, then we'll be showing you an orange light show. You should probably double check this, just make sure it's fine. And if it's red, then we know there's no way it's anywhere near what you want, so there's no point doing it. And then the other thing is the ease of setup. So with those Araco markers, currently you need all 4 for it to work. I'm hoping I might be able to get that down to just 3 and still be able to get accurate measurements, but then again, we're trading off the accuracy improvements there. So that's more of a fallback for if things start to go wrong. So how how's this project helped me already? So I had a little experience with computer vision technologies before, but in that module it was mostly just copying the code and pasting it and trying to get as many marks from that as possible. So this has helped me a lot actually understanding what's going on behind the scenes, making sure that I know what's happening, different methods that we could use to achieve better results. Planning. I tried to plan at the start and I decided I could do a lot more stuff. I was hoping at the start of this to have it on a Raspberry Pi. That's not happened. That leads into the third point, deploying to different environments. I've also learned that they made Docker for a reason. Rhymes like that one. I tried halfway through last week to switch to a Raspberry Pi, and then I quickly learned that it did not want to do that because I've been doing all my development on a laptop. A lot of issues with the camera API and just all the Linux things going wrong. So this has really helped me to appreciate that you can't just quickly switch something over. You've got to make sure you plan ahead and know what the final product is going to be and where it's going to be deployed and all those different things. So yeah, I'll also be showing a live demo after Christian's after we've moved over to Sam. Oh, okay. I'm going to get our live demos now.
So, as promised, here is the live demo of my setup. This is the rig that I'm constantly using so I can emulate the ceiling of the factory. As you can tell, the camera is hanging from here and is looking directly down to a piece of paper, if you can see there. And here on the screen, the output, the results. It gives the 211 millimeters dimension of the length of the piece of paper and 150 millimeters width of the piece of paper. You can already see a 1 millimeter deviation because the angle is not perfectly vertical. If I place an object here, for example, my wallet is gonna output its dimensions in mils. It doesn't do the thickness yet. We can also place a card, which I also used for the images. In the presentation, is gonna output the dimensions. At the moment, the tolerance is 2 mils, to say so. So it's around that. It also deals with irregular shapes. It's gonna show just the width and the length of it. And I'm using some of Felix props. I hope he doesn't mind. Yeah. It shows that I can also handle the parameters, so I can, because as you can tell, it's struggling a bit to find the bounding box, but I can modify the parameters here and now it detects it better. So yeah, that would be my project in a nutshell with this demo. And now to Felix.
2 seconds.
the same tiny factory.
Yeah, you can also use Philips.
Yeah, that's so. Webcam. Hopefully it doesn't crash. There we go. Looking from the webcam, we have our image which has been cropped down to just the area within the four things. If you look at Christian's screen, that's what the webcam's saying. And then we're cropping it down just so we get the bits that we care about. We can then place any shaped object in, for example, the star as an irregular shaped object, and it'll give us all those different 10mm sides. Not the easiest to read, but obviously that's something I'm going to work on. So yeah, it's one of the benefits of mine over Christian's is that, sorry to say it like that, I feel really bad now, is that I can get the measurements of all the different sides. You can see on the octagon that it's a bit, it doesn't exactly like what's happening. It's trying to find different sides, place a square in there, and it'll just about find it. For an easier one to read, I did prepare for this to go slightly wrong, as you always should. Here's one I prepared earlier, he says. There you go. With the different marker in the triangle, and we have the 61mm by 60mm square, and the triangle up there with accurate measurements. All of those are within around a millimeter. And yeah, that's it from us. We're going to let Stanley introduce their take on the same project.
Doing the slide first, do you want to do a live demo?
I'll do the live bit first.
Live bit first. Right.
So we've got a very makeshift setup here, but we've got the actual part below. So we're using the reference object there, which is my power bank, just because it was here. And so we've got a webcam, and you can put this up and just run this here. And then if you can see on that screen there, it uses the reference object, the pink writing, and then if I can get it in, there you go. It's got the actual object, the roll bar, and it's got the width, the height, then that C value there is the distance between those 2 points, which is the thickness of the bar. So we're specifying that we want that area there, and we want the distance between the two contours on either side. And these are the values, unlike the other guys, we're doing it so that we were thinking of what values the manufacturer would actually want. So instead of just the length and the width, the actual thickness of bars. And we've also got it so you can use an image as well. So if in case the manufacturer's there, because at the moment we're using temporary setup here, but if they want to just come along, take a picture and then scan that, we can do that. It's not very accurate at the moment, but that's what we're going to work on over the next 2 weeks. And there you go. Over to you, Zan.
Right, over to
Right, hello, can you see me? Nice to see you all from Jordan. I hope my presentation, I'm not sure if it's on, but if not, I can share my screen. If that's the case, just let me. All right, okay, there you go. This is the thing. Right, so that should work, I guess. Hopefully the internet is not too bad from Jordan. But yeah, Right, there we go. Present. Right, so I hope you can all see this. I'm not sure, I can't really see your responses. So basically, me and Sam, we both worked on this project, Vision Systems for Object Dimension Detection. We're both mechanical engineers. We have recently been working on a startup company that is to do with providing digital solutions for SMEs. And we are in the process of launching it. So this IoT placement has been given us like a first step of actually playing around with some technologies and trying to solve some challenges. Right. So a lot of the guys already pretty much explained everything that I was going to explain, but I wanted to give a bit of a different brief and talk about the user cases that this can be applied to, this vision system technology for object dimension detection. So one thing we can apply it to is basically we can create a dashboard in order to display the results. So this dashboard will act as a way for the operators to execute the code and have them visualize the results automatically from the dashboard. So any objects that are identified and recorded will then send an alert, for example, if the object is out of range that specified, the threshold, for example, just in a sort of a way to let the manufacturers know that this is bad condition. Yeah, just a way to optimize it. Another way we actually thought about is, do you really need to fix cameras in order to measure the dimensions of the objects if you don't have a lot of assets? So say you're just measuring dimension of 1 or 2 assets. Can you not just create some sort of a web app that basically allows manufacturers to use their mobile phone, which we actually realize are actually like normal mobile phones, like iPhones, have quite a good camera capabilities, functions. So as demonstrated by Sam just a few minutes ago, we basically used an image in order to record and measure the dimensions. So obviously that depends on how many assets. So if you have a lot of assets that you're trying to measure at the same time, it's probably not a very good example. Then you do a live feed of the camera instead and fix it. But yeah, this is just like another example we thought was unique. One thing else we looked into actually, it was a bit out of this challenge. It was not in the scope of the challenge, so we didn't really present it in the demo. But we actually used this example vision systems for the purposes of quality inspection. So we basically, we got 2 objects, like it was like a stick, 2 sticks, and we cut one object like 2 centimeters, and we run it through a machine learning algorithm, and we were able to classify it through the machine learning algorithm so that the algorithm can automatically detect which one is a good condition and which one is a bad condition. So the user case for this would be, for example, for quality inspection, if you have objects that deteriorate over time and you want to know whether or not this is a good quality or a bad quality. Obviously, human eye can only see so much. So with machine learning vision systems, you can there's all sorts of applications that you can use this for. But yeah, I mean, this is sort of a quick summary of what's been going on. For the near future, we obviously will try to lessen that tolerance, try to get more accurate dimensions, especially when it comes to the thickness of the measurements. But yeah, we're going to be doing a lot more image processing in the next few weeks, try to get more data and actually see if it works. Right, so this is a bit different to what the presentation that we've seen. So myself and Sam, as I already mentioned, we're both sort of a startup student project. So we're actually been working for the last 1.5 years on a startup to do with digital technologies. So here I'm introducing to you PredictTech, empowering the UK through the new industrial revolution. So yeah, I'm going to be talking a little bit about that. So PredictTech is basically a UK company we're very excited to launch this year, and it's set to provide a scalable and affordable IoT digital solutions for SMEs, manufacturers. So basically, according to various government reports, including predominantly Made Smart Review, is that digital technologies is the key factor at improving efficiency and productivity. And there's actually a graph. It's not here right now, but I'm going to describe it. So there's a graph that's been published by Made Smart Review, which shows the manufacturing output of the various countries, developed countries around the world. And the UK actually seen the largest decline since the 1990 to 2014. And one of the main reasons for that is due to lack of adoption. And when we look deeply into the UK manufacturing sector, we realize that the issue is with SMEs not having the right skills, resources, the technical knowledge, and actually the funds to invest in that. So this is why we came up with the startup idea. Is we really want to help SMEs in realizing their potential in their sector and actually use these technologies to leverage data and be able to come up with really good insights about what's going on in their machinery. So yeah, this is our solution, basically, just a brief overview of what we mean by our solution. So basically, all of these technologies, which have been already demonstrated in this presentations today, is that all of these technologies, they are all over-counter technologies, Raspberry Pis, network gateways, Arduino, sensors. All of them are very accessible, very affordable technologies, and the skills are there. But the problem is how you utilize these technologies in order to solve unique business challenges. And this is what we want to do with our solution. Is we want to work with manufacturing companies, with SMEs. We want to provide them with a personalized approach, with a unique approach that identifies the problems with their organizations and be able to come up with custom-built solutions that can actually help them in their journey. So a lot of businesses have actually tried to access this market, but they've actually failed. A lot of them failed. It's because they always try to look for the more expensive approach. So using various complex data acquisition systems to gather data, et cetera, and all of these processes have been out of reach for SMEs. And also not only that, but a lot of companies that you see, they don't really, they only focus on one value chain. So for example, we want to provide IoT solutions, full stack IoT solutions, so hardware and software. We want to offer 24/7 customer support. So basically we want to work with these businesses. However, from our market research, 90% of the companies that we've actually seen is they only focus on one part of our value chain, which is, for example, the software. And it usually is a data analytics software, and it's very generalized. It doesn't really work on the challenges, the unique challenges of various businesses. So we really want to, work with these companies. We want to be part of their business, pretty much. And more importantly, we want to take them on a journey because it's a step-by-step process, and we want to start with them as a process of cycle and improvement and investment, right? So that they slowly integrate into that IoT digital technologies atmosphere. But yeah. So our team, so it's basically me and Sam. So far, we're both mechanical engineers. I'm a graduate mechanical engineer. Sam is still a student. He's doing a placement now at Boeing. He's going to Boeing for a 3-year placement. So basically, we didn't come up with this idea overnight, and we're like, okay, we're gonna go and do it and whatever. Like I said previously, we've been working on this for the last 18 months. I did a dissertation actually on this topic titled Industry 4.0 First Steps for SMEs. I was looking into the Sheffield area specifically, trying to assess the barriers of entry for SMEs towards digital technologies. And part of my dissertation, I had to produce a affordable and viable solutions for SMEs that can act as a first step for them into IoT. Sam, on the other hand, he's been very active with his engineering career. So he's been part of SELA, which is the Sheffield Engineering Leadership Academy, which work a lot on digital adoption of IoT. And he was recently working with Tinsley Bridge, looking into machine downtime and how to gather data, collect it, leverage into insights and whatnot. So around us as well, we have an advisory team from companies such as Siemens, the AMRC, Entrepreneurial Spark. We have business development support. We have technical support from all across. So really, we just want to build a team that that is able to solve any challenges and prepare for everything basically. But yeah, I'm not sure if there's anything more to say. But right. So if you're interested, if you're a manufacturing business organization interested in finding out the potential value that can be brought using digital technologies, please get in touch. Right. One thing I sort of just remembered now, I forgot to mention, is we were just we took part in a pre-accelerator program, part of the University of Sheffield. It was the first pre-accelerator program, and part of that pre-accelerator program was a competition to pitch the business idea. So we, fortunately enough, we managed to win that competition, and we've been awarded with a £10,000 grant to kickstart our business. So that it's going to really help us right now, because we've been doing so much market research, and now we're ready to take this into actually a practical approach and start prototyping. So we're really interested in getting in touch with businesses that have any challenges for us to solve, because we love doing that. And even if you're a business that is not looking for a commercial IoT product, if you're just interested in just getting a feel for what is IoT and how I can solve some of my challenges with no expectations, then also please get in touch. I mean, you've seen so many challenges today, amazing challenges from amazing people with various skills. So there's definitely a lot of potential. And here's our contact details, and I hope you get in touch with us. Thank you. That's it. Right, so let's close the screen. Can I?
Thanks so much, Yazan. And based on that presentation, I have no doubt that you and Sam are going to be a huge success. The reason I invited Yazan and Sam to present in that way is because they have been on this pre-accelerator at the University of Sheffield, and they are the winners. And we really wanted to give them an opportunity to start putting all of their research into practice and start prototyping so they become ready for market. So we've been really, really pleased to have them involved in this project. And essentially, it's giving the indication of where we want to go with this. This has really been a pilot about getting companies like PredictTech starting to experiment with Internet of Things, helping them to create prototypes to bring to businesses to address their challenges. So I think you can see the kind of pathway that we're on. In terms of questions, we're going to start off with Yazan, with him being online. Ramsey, I don't know if you have anything, or I can pick one up. Okay, so Yazan, now I can see you now moving into practice with your startup.
Right.
With companies like Tinsley Bridge, sort of more traditional manufacturers, how do you think you can kind of persuade them? What kind of top 3 things would you say to them to say, give us an opportunity? Because not all of these businesses have an IT manager like Alex Kelly. So what would you say to a kind of head of production at a typical manufacturing SME in the region? How would you persuade them? What top 3 things?
Right, thank you for the question, Kerry. So actually, one of the, I didn't cover this from my presentation, but one of the aspects of our business is this sales cycle that we're undertaking. So we realize that this is a new area for a lot of manufacturing companies. And in order to be able to start talking to them about this industry, you can't really use IoT. You have to, because it really scares a lot of manufacturers, just the truth of it. So really, what we want from manufacturers, from companies, is we want to tell them, okay, let us, look into your machinery, give us an access to your warehouses, and let's see where we can bring value to your processes. So I think this is a good intro-level conversation to sort of get a feel of what they are expecting, because I don't think being very technical with manufacturers, like you mentioned, they're very traditional. So it's using IoT is a very not a very good word, because it scares a lot of people into thinking, oh, robots going to steal people's jobs, whatever. So it's all about trying to get them to understand the value of what you're actually trying to bring, and the value is that you're trying to leverage the data that they're collecting. Like, they don't really have the data, but it's about collecting that data and getting the insights from it. So yeah, I think it's just all about talking to them and see if they have any challenges that you can try and solve with your ideas.
Thank you so much, and thanks a lot, Yazan. And we'll move over to Christy, Felix, and Sam now for a question. I don't know how we organise that. Just if you come on stage, I can say it from over here.
Does anyone have any questions?
I have a question. Go for it. Okay. Yeah, very socially distanced. Can hear me, yeah. Okay, guys. So you've done all this great work. Thank you so much, and brilliant demos, by the way. They all really worked well. So thanks so much. So you're at the kind of theoretical kind of level. If you were all speaking to Alex now, head of IT at Tinsley Bridge, how would you say he should take, what next step should he take, and why should he do it? Like, what actual efficiencies is it going to bring? Could you touch on that? Yeah, go for it, Christy.
I think I would start with the second part of the question, and I would advise him to go with this method because it is easy to implement. As I said, I don't really have coding experience, and I managed to do something that was outputting a result within 2 weeks. So I think with a couple of months of developing, you can do something that can really perform well in warehouse conditions. And yeah, just go for it. And from what I've seen, you can make it also wireless and remote accessible using the Raspberry Pi, and you can pretty much automate the whole measuring system just by using the Raspberry Pi and a short Python script.
Yeah, I mean, that's a really nice answer. And I think, a lot of manufacturers around the region, they'll be very wary of this type of thing. And you've just shown, like, in a couple of weeks, actually, you can bring a kind of prototype solution. So thanks so much. Yeah. Felix or Sam, did you want to speak to that?
Well, I guess it's just increasing efficiency. Like, instead of having that one person wasting the 2 or 3 minutes trying to get into the jig, making sure it's fine in there, and then moving on to the next bit, it's just putting it down, giving the computer a couple of seconds for it to do it, and then moving it off. I mean, it's just increasing that efficiency, because over the year, of the however many years, that'll start to end up.
Yeah, absolutely. Yeah, and this is the type of incremental efficiencies you need to bring for overall gains. Lovely, thank you.
Yeah, not only that, but if you can do it on this part, you can find it elsewhere in the factory, because they were saying about the security cameras, so you could look at other places where you can use the same technology and just adapt it to there. And then you carry on through the journey and trying to get the whole factory.
Yeah, absolutely. I noticed you and Yazan were talking about dashboards, kind of bringing all the data together. Thank you for that. Yeah, go for it, Christy. Yes.
Sam just said, Alex was also talking about the conveyor belt system. So our application would work great on a conveyor belt system. So not only measurement, but also object detection. as I was talking during my presentation as well, because based on rough approximations of the dimensions, you can also identify the objects as well. Because as you guys saw in my live demo, my measurements are only width and height, but I think that's enough for this kind of system to identify an object and say, okay, this one goes there, this one goes there, or yeah.
Superb, thank you so much. Any more, Ramsey?
Yeah, I mean, I was only going to touch on a related thing, because whilst there's been some fun, friendly rivalry with these guys, what I really like is actually they're three quite complementary technologies. I mean, Christian's been very modest here, but his, with a little more work, will work in quite noisy settings with kind of yellow industrial lines and all sorts of stuff. That's a really fun way to find the parts in the factory. Meanwhile, Felix's one, you have to set up a few targets, but suddenly you get a massive benefit in accuracy for that. And then, of course, the guys examine that. They're doing a lot of things, like they say, online, having captured it from all sorts of different sources. I mean, we're being a bit cautious saying, well, we think we might be able... No, actually, some of this technology will just work off people's phones, off CCTV cameras, and suddenly you're applying some serious kind of quality assurance stuff without having to have a whole bunch of quality assurance engineers putting things in and out of gigs. There's a lot of opportunities for this to sort of seamlessly get into production processes. And I mean, touching on your Zam's point, I don't know whether they're necessarily scared of the word IoT, but definitely coming in with a bunch of buzzwords to an established old-fashioned engineering business might be a bit off-putting. Whereas what's been nice about this process, and with another week or so, you've got physical things you can show people. Look at this, I can measure your product just using your iPhone. And I think that's probably going to be quite a sales pitch for this. We can see it in action in some real settings. So.
Thank you, Ramsey. Well, thank you, everyone. If you like, I'll just do a wrap up. Ramsey, you stay there.
Thank you.
Okay, well, many thanks to all our student speakers. I mean, honestly, you've done a fantastic job. Given it's been such a short time, you've made remarkable progress. And I think all of the challenge setters, as you can see, lots of claps going on. You know, they'll be very grateful to the time and effort that you've put in. And on that note, also, we should say thank you to our challenge setters. As you, many are here today, and they've joined in. Sadly, a couple haven't been able to join us, but because it's recorded, we will be able to still share the whole event with you.
And on the subject of thanks, we should of course make sure we thank Barnsley GMC for hosting our students. We should thank Ben particularly. None of you guys can see him because he's the one carrying the camera around the room and pointing at everything and doing the seamless transition. So thank you, Ben, and thank you, Barnsley, of course. And thank you, Kerry, as always, for telling these things up.
Thank you. And ditto, I would say, also from the University of Sheffield's point of view. We've got Walter Bassage here, one of our mentors, who's been a real stalwart and here helping students on a daily basis. And Steve Jubb and Mike Fawkes, thank you so much. And anybody else, and Ramsey, of course, if I haven't remembered somebody. So yeah, big appreciation. Actually, there is an opportunity now, actually for students and mentors alike. If you want to have more dialogue, you can go on to Airmeet and meet people for specific conversations in the lounge. So all you need to do is go into the lounge and grab a seat on a table, and you'll be able to see little icons to suggest other people are there for a chat. We appreciate, it's been a fairly lengthy session, so please stay if you can, but we will understand if that's not possible.
You might need to give the students a minute to go
and
somewhere they can sit.
Yeah, exactly. Just give the students a.
You're interested in talking to any of them particularly, then by all means, message them and invite them to a table. We'll try and spread them out.
Exactly. Yeah, give them a few minutes just to get on. Well, on that note, thank you so much for your company and for joining us. And we'll look forward to bringing you more IoT news soon. Thank you.